my name's Amelia, and today we're going to be looking at deriving the torsion in a shaft equation. So from this photo, we can see that the initial length of the shaft is L initial, and this is the radius over here, and the perpendicular angles of the vector fields here. And this is the axis that the entire shaft is rotating around. From top view perspective, we're looking at the radius and alpha. This is the initial equations we're going to work at. It's important to note that tau is represented by the torsion modulus times gamma and F over A. Those two are going to be very important later. Let's start with the moment. We're going to realize that moment is radius dot F sine theta, and because the angles that we're looking at is perpendicular, that's represented by pi over 2, and we know that sine pi over 2 equals 1. So that simplifies into this equation. We're going to derive that equation and arrive at R initial times tau is dA, and that is because dF can be found by rearranging this initial equation that we had from the beginning. Now that we substitute that into here, we can have this little trick where we multiply the entire equation by 1, or this side by 1, and we will have tau over R initial, which can be taken out of the integration that we're going to do here. And now that we have this term by itself, we can realize that that is the polar moment, which is represented by J. That's over here as well. Now we want to isolate tau. Tau is by itself. We're also going to realize that at this point, tau can be recognized as these two equations. And since this was initially derived by this, we can set these two equations equal to each other and find and break down what gamma is. So gamma from up here is just R d alpha over dx. In this specific photo, what we're referencing is alpha is the same as d alpha, and L is just that initial length over here. So now that we rearrange, we come around to find that this is equal to gamma. We're going to plug that in with G and realize the R naughts can cancel, leaving us with alpha as m times the initial length over the torsion modulus and the polar moment. From here, we can break down what polar moment is, and for a cylinder, it is pi over 2 times r to the 4th. Now that we arrange that equation, we arrive to the solution, and that is the equation for the torsion in a shaft.